this video, we're going to look at the empirical formula and the molecular formula. Here, if you look at this compound, it has 6 carbon, 12 hydrogen, and 6 oxygen. So these numbers show the exact number, the actual number of the atoms that make the compound. So this is, we call it a molecular formula. But if we find the lowest ratio, the lowest number of the atoms, lowest ratio of the atoms that makes the compound, then we call it the empirical. So this is empirical formula, and this is molecular formula. What number can we divide all these numbers over to find the lowest number? So if we divide all 6 and 12 and 6 over 6 over 6 over 6, these will give us 1, 2, 1. So the molecular formula of this compound is C1H2 oxygen 1. So this is the empirical formula. I'll give you another example. If you have H2O2 hydrogen peroxide, we can divide this 2 and this 2 by over 2. Over 2 will give us 1, 1. So the ratio here is going to be 1 to 1. HO is the empirical formula of this formula. But if we cannot divide both or all the elements with one number, then we do not have an empirical formula. If you have this example, H2O, now we can divide the 2 over 2, but this one of the oxygen, we cannot divide it over 2. So the empirical formula is going to be the same, H2O. Another example, NH3, so it's going to be the same, NH3. We have H2SO4, and many students in the monthly exam made a mistake here because they thought they can divide this over 2, they can divide this over 2, but what about the sulfur? They cannot divide it over 2, so the empirical formula is going to be the same. So it's going to be H2SO4, the same. This is the molecular formula and this is the empirical formula. Now we know what is the molecular formula is the formula that shows the actual numbers of the atoms that make a compound, but the empirical formula shows the simplest ratio of the atoms that are present in a compound. So here we're going to look at some examples. Find the empirical formula of a compound containing 60 grams of magnesium and 40 grams of oxygen. Now, to solve questions like these and to find the empirical formula, first we're going to make a list of the atoms we have. So we have magnesium here, and we have oxygen. So the magnesium here, how much is it? It is 60. So we're going to write 60 grams, and the oxygen here, it is 40. Now these numbers, we found them from the question. It says 40 grams and here 60 grams. Now the second step, we are going to divide over the relative atomic mass to find the number of mole. So here we have magnesium is 24, the relative atomic mass, 60 over 24, and 40 over 16, because this is the relative atomic mass of this one. This will give us 2.5, and this will equal 2.5. Now we have these numbers. What number can we divide them both with to have the lowest number? So if we divide them both over 2.5 over 2.5, this equals 1, and this equals 1. So the ratio is 1 to 1. So the empirical formula is going to be 1 magnesium and 1 oxygen. This is the empirical formula of this compound. So let's have another example. If you have the percentage instead of gram, it's the same. We'll deal with that just as if it is grams to find the number of mole. So here it says, find the empirical formula of a compound containing 92.3% of carbon and 6.6% of hydrogen. So the atoms we have here, we have carbon and we have hydrogen. Now we're going to put the numbers of these from the question. So 90, the carbon is 92.3, and the hydrogen is 7.7. Now we're going to divide over the relative atomic mass to find the number of mole. So this carbon is going to be over 12, and this hydrogen is going to be over 1. So this will equal, if we divide it, it will equal 7.6 and something. Let's round it, it will be 7.7, and this equals 7.7. Now we divide them both with one number to have the lowest ratio. This we can divide them over 7.7, and this we can divide it over 7.7. This equals 1, and this equals 1. So the ratio here is 1 to 1. The empirical formula is going to be 1 carbon and 1 hydrogen. This is the empirical formula, and we found it. Let's have another example. In this example, it is a little bit different. It asks us to find the empirical formula. Find the empirical formula. Then it gives us the MR of the compound and asks us to find the molecular formula, because look here, H2 CH2O. This can be the molecular formula of many empirical formulas. This can be C2H4O2. It can be C3H6O3. It can be like C5H10O5, and so on. It can be this one molecular formula, can be it can be the empirical formula of many thousands of these molecular formulas. So we want to find the exact one. Is it C2H4? Is it C3H6? Is it C5? So how can we find this? First, we're going to find the empirical formula, just like we did before. So here, we'll make a list of the elements we have. We have a compound containing 80% of carbon. Here we have carbon, and we have hydrogen. So the carbon is 80, and the hydrogen is 20. Now we're going to divide over the relative atomic mass to find the number of mole. So carbon is 12 over 12, and this hydrogen is over 1. So this carbon is going to give us 6.6 something. So let's round it, 6.7, and this will give us 20. Now we will divide these two numbers over one number to have the lowest ratio. So if we divide them over 6.7 and this we divide it over 6.7, this will give us 1. This will give us 2.98 and some number. Let's round it to be 3. So now we have the ratio. The ratio is going to be 1 to 3. So let's make a line here. So this is the ratio. So the empirical formula is going to be CH3. Now we found the empirical formula, and this is the first question, the first demand in this question. Now we're going to find the MR of the empirical empirical. So the MR of the empirical is like we found the relative formula mass. So C is carbon is 12 plus we have 3 hydrogen, 3 times the relative atomic mass of hydrogen 1. This equals what? Equals 15. Now we have this number, the empirical formula unit. Now we're going to divide this over the MR. It says if the MR of the compound is 30, find the molecular formula. So we're going to say 30 over this number of the empirical formula unit over 15 equals 2. Now we found this number 2. This number 2, we are going to multiply the empirical formula over this number. So it's going to be 2 here. 2 times CH3, the empirical formula. This is going to give us C2H6. So this is the final answer. This is the molecular formula of this compound. I hope this was easy. So just to have another example to have better idea is going to be this example. A compound containing 67% carbon, 2.22 hydrogen, and 71.11 oxygen. Find the empirical formula. This is the first demand. Find the MR of the compound. If the MR of the compound is 90, find the molecular formula. So we're going to make list of the elements we have here. We have 3. So the first one is carbon. The second one is hydrogen. And the third one is oxygen. So here, the carbon we have 26.67. The hydrogen is 2.22. The oxygen is 71.11. So we're going to divide them all over their relative atomic mass to find the number of mole. So this is going to be over 12. This is going to be over 1. And this is going to be over 16. So how much this will equal? This will give us 2.22. This equals, let's use another color here. So this equals 2.22. This equals 2.22. And this equals 4.44. Now let's divide them all with one number to have the lowest number. So which number can we divide them all over to have the lowest number? If we divide this over 2.22 and this 2.22 and this over 2.22, this will give us 1. This will give us 1. And this will give us 2. So the ratio is 1 to 1 to 1 to 2. The empirical formula of this compound is going to be what? Is going to be 1 carbon, 1 hydrogen, and 2 oxygen. The oxygen is going to be 2 because the ratio of it is 2. Now let's find the MR of empirical formula unit. If empirical is going to be here, the carbon is 12, just like we find the relative atomic mass, and the hydrogen is 1, and plus the oxygen we have 2 atoms times 16. This equals 45. Now this is the MR of empirical. Now here we have the MR of the compound. We're going to divide it over the MR of the empirical unit. So it's going to be 90 over 45. 5 equals 2. Now we found this number 2. This number, we are going to multiply the empirical formula over by this number to find the molecular formula. So it's going to be 2 times CHO2. This will give us C2, C2H2O4, and this is the molecular formula, C2H2O4, and this is how we found the molecular formula. So this is the empirical formula. Then we find the MR of the empirical formula. That is just like we found the relative relative formula mass. Then we found the empirical formula. So I hope that was helpful. Until the next video, ciao.